There's two approaches to this question. You can either just write down the numbers from 1 to 15 and then see if you can get them by adding three squares, or you can look at all the different arrangements of adding three squares that are less than 15 to start with. So I'm going to talk about the first method because it's solid, and then I'll talk about the second method. So three squares. We're allowed to use 0, as the question says. So we've got 0, 1, 4, or 9. And then really interested in 1 to 15, so I'm not going to use 16 at any point. And then we can just sort of systematically increase and figure all these out. Okay, and when we get to 4, we have to, we can't use 4 ones or anything, so we're going to have to jump and use 4. Okay, now for 7, there's no other square number that we can use that's higher than 4. So actually we have to use 4, and then we're going to have to try and get 3 from two square numbers, but that's not possible. So 7 is not possible, in fact. But then for 8, we can use two 4s. 10, now remember we've got 9 in there, and also could have written 9 as 0 plus 0 plus 9. 12, it looks like we're in trouble because we could use 9, but then we need 3 from two squares. But actually, you got to remember that 4 is there as well. We couldn't do that over here, but now we've got 4 plus 4 plus 4. And 13, then back to we can use 4 and 9. And 15, well, we can't use two 9s, so we're going to need a 4 and a 9. But then there's no way we can get anything here. So 15 is not going to be possible either. And therefore, how many can be written? Well, it's everything apart from two of them. So there's going to be 13. So let me talk briefly about the second method. Arguably, it's a bit better because it kind of stopped. I don't know. I suppose you can't miss any out. I think it probably maybe have to write more calculations. But if you just write down all the different arrangements of them, like 0, 0, 1, 0, 1, 1, and so on, you can see all the numbers that you can get. They're all going to be different, in fact. So we see that there's 13 arrangements. And so although we don't, we'd have to look and say, okay, it's 7 and 15 that we can't get, you can see 13 possible totals. So it must be somehow that 2 cannot be obtained. Both approaches are good, I think, for if you're doing higher numbers. You can see why this approach kind of wins out. Um, but for this question here, I don't think this is a bad idea at all. So Lagrange managed to prove that it actually, if you take 4 squares, it is possible. It's pretty cool. And you might want to look into that. In 1770, he proved that. I've never seen that proof. But here we see it's not true, and these would be called counterexamples to the proof. And but proving the 4 so, sum of 4 squares that you can do it in will be, I think, quite challenging, but have a look into it.